Hello everybody, I'm Zephan and this is my geography in my backyard project. I decided to do my project at Senator Frank L. Madla Natural Area in Helotes, Texas. Give me 1 second. Based on my observations, as well as what the past decade of satellite images shows from Google Earth Pro, this natural area seems to be relatively dry outside of the season of spring. Here I'm going to show you some of these images from Google Earth Pro to give you an idea of what the park looks like at different times of the year. And then we can contrast them with the pictures from that I took in the middle of spring. So here's the most recent one. I'm just going to go through the years. And we do see how the park changes in appearance over the years and seasons. So here especially we see what I mentioned about the natural area appearing dry in comparison to the park around April where Madla is quite green. And what do we attribute to greener pastures? An increase in precipitation. From my visits at Madla Park, it's rich with evidence of erosion and weathering by multiple means. While there aren't any perennial or intermittent streams in this area, ephemeral streams seem very likely to occur. These images show why I believe ephemeral streams happen in certain areas of Madla Park. First, there are several spots in the park that feature either a dramatic change in elevation or low points where potentially weathered rocks have accumulated. This change in elevation provides us with ideas as to where ephemeral streams would occur in the instance of heavy rainfall. As far as weathered rocks are concerned, we see a lot of smaller rocks where large tree roots and large stones meet. So we see that here. I also saw some of these rocks differed in texture and sharpness. Some of these rocks were quite smooth, while others were a bit more coarse and sharper. This can be attributed to some of these rocks being eroded off at different times, and the smoother they are, the longer they have been in these low elevation areas where ephemeral streams would flow. And these rocks have congregated together beneath large trees, showing several processes. One, erosion has occurred around these large old trees, which is why we can see sections of exposed roots. And two, smaller rocks are being displaced to areas of lower elevation, usually in these eroded areas. So we see that right here. Physical and biotic weathering are also quite apparent in this park. Here we see the fracturing of rocks in the park. Biotic weathering is seen in the images where small plants are responsible for the splitting of larger rocks. So here you see it splitting the rock. We also see it here. And then physical weathering, on the other hand, is seen in images where no plants or chemical processes take place and are a product of the weathering by mechanical processes. So it would be these. The last couple of pictures I would like to talk about pertain to there being different types of geologic layers or strata. In these images, there appears to be a distinction between layers where the earth goes from a tannish orange with smaller grains to larger gray rocks. This provides us with a bit of insight into what rocks made up the surface of the park many years ago, but are now covered up by this tan layer of rock. Both appear to be sedimentary rock, with both having components of other rocks in their composition. So we see the tannish orange here and the larger grain stones here. While Malda Natural Area didn't feature a flowing river or an intermittent waterfall, this park did feature numerous examples of processes such as weathering, erosion, geologic strata, and ephemeral streams. These observations give us an idea of how this park is changing now and how it has changed over the course of many years. Thank you.